I'm going to help you set up the most difficult of the math problems for this lab. It's an orographic lifting problem. And if you flip to table 1 in the lab, you'll see this lovely diagram, which was created by a former professor of mine, those many decades ago, a man named Dr. Phil Kane. This is a bisection of the state of California, and in this, I guess, Phil lives on. If you look, you can see San Francisco is at A, Mount Diablo is at B, Stockton is at C, Yosemite Valley is at D, Mount Dana is at E, and Mono Lake is at F. I'm going to read what's above table 1 to you now and go through it. So it says, a parcel of air with a temperature of 65 degrees and a relative humidity of 85% comes onshore from the Pacific Ocean at San Francisco, A, and begins to head eastward. So there's San Francisco, 0. It's at sea level, okay? As it begins to rise along Mount Diablo, which is B, you can see B right here. Very good. As it begins to rise along Mount Diablo, it reaches its condensation level at 1,000 feet and continues to the top of the mountain, which is 3,000 feet, before descending into the Central Valley and passing Stockton, which is letter C and 500 feet above sea level, right there. It then begins to rise along the slopes of the Sierra Nevada. At 3,000 feet, it reaches its new condensation level and passes over Yosemite Valley, D, right there. Yosemite Valley is 4,000 feet above sea level. Then continues to rise to the summit of Mount Dana, which is E, at 13,000 feet, right there. The air then descends to the Mono Lake area, which is 7,000 feet above sea level and represented by letter F. Okay, so let's watch it happen. Here we go. The air comes onshore, rises up Mount Diablo, descends down into the Central Valley, then rises up the western side, the windward side of the Sierra Nevada, then descends into Mono Lake and that leeward side of the Sierra Nevada. Let's go through it. So as the air comes on shore, it's going to reach its condensation level as it comes up Mount Diablo from San Francisco. Clouds are going to begin to form, which means, of course, relative humidity 100%. And this is going to happen at 1,000 feet above sea level. Okay, so we're going to switch rates there. Then the air is going to descend from B, which is Mount Diablo, down to Stockton at 500 feet. Now look, you're going from 3,000 down to 500 feet. How many thousands of feet are you going down? 2,500, which means you're going to multiply whatever rate you're going to choose here, as we're going to see in a minute, by 2.5, representing 2,500 feet. Okay? Then the air is going to continue to rise up along the Sierra Nevada, and as it does at 3,000 feet, it reaches this new condensation level, which means we switch rates again. It's going to continue up to the top of Mount Dana and then descend into Mono Lake area. These are the rates, of course, we would use. From sea level in San Francisco up to 1,000 feet where the condensation level is at as it rises along Mount Dana, we use a DAR. Then the WAR from 1,000 up to 3,000 feet. Then the DAR as the air descends from 3,000 down to 500. Then the DAR from 500 up to 3,000. Okay, what are you going to be multiplying by? 5.5 times what? From C up to 3,000 feet, you'd be using 2.5, representing 2,500 feet. Then the air continues to rise all the way up to the top at Mount Dana at 13,000 feet. Then it descends into the leeward side valley at 7,000 feet. Now look, of course, I covered up Yosemite, which is letter D, when I put the cloud on there. But you can see, there it is right there. Okay? Good. Good luck.